Hi, I'm Brian from Simply Brian Enterprises and welcome to my channel. In today's video, we're going to be looking at the homework solution for TopTechBoy's Raspberry Pi class, lesson number 18. Well, wait a second. There was no homework for lesson 18. Paul did a simple demonstration of the joystick and then moved us on to lesson 19. So what's this video about? Well, I will show you. I set up the joystick and decided there was enough to talk about that it was worth making a homework video for. So if you'll bear with me, we're going to take a look at the homework for the non-homework maybe for lesson number 18. And as usual, we're going to look at the hardware, run the program, and then look at the code. So the first thing I want to do is look at how we have the hardware wired up. I have, if you'll excuse me here to put this up, I have my joystick wired plus and minus 5 volts up at the top. The x-axis, which is an analog output, as well as the y-axis, are going to the ADC0834 chip over here. X is wired to pin 0, Y is wired to pin 1. And I was wondering, so I had to look it up, how is this switch wired to the joystick? Because technically I'm taking 5 volts in, and this joystick button has to go straight to a GPIO pin over here on the Pi. So the question I had is that 5 volts? And the answer is no, it's not. The switch does not connect to the 5-volt rail, it connects to the ground rail. So that means regardless of what microcontroller you're using, you're going to wire or you're going to program the GPIO pin as a pull up so it's always hot. And then when you when you press down on the switch, it's going to connect it to ground to bring the pin low. It's a digital input high and low. So I thought that was kind of ingenious on the designer's part. Instead of sending 5 volts, we are sending ground out the switch port. It should also be noted that even though the X and Y are 5 volt, that's okay because the 0834, the ADC0834 runs at 5 volts and it's not going to fry the Pi by any means. Alrighty, so let's take a look now. We're going to run the code. So I have a small program written here. And you can see that X and Y are hovering somewhere around 128, which is what we'd expect when it's to the center. And if I move the joystick left, I go to 0 on the x-axis, 255 on the x-axis if I go to the right. If I go up, I get 0 on the y-axis, and 255 is down. And you can see that my button state is always 1. That's because, again, it's a pull-up pin. So when I press the button down, it goes to 0 because it connects it to ground. And as always, we're going to use our friendly cat talk button to gracefully exit the program. So that's kind of neat. It shows us that we have wired everything correctly. It's good diagnostic to show things are working, but aren't joysticks supposed to be fun? Aren't they supposed to play things? Shouldn't we do something kind of interesting with it? Well, let's see what this program is about. Maybe this will have something fun for us that we can do. Here we have a little red sphere in two-dimensional space rather. And you can see over on the left that I have the coordinates of the sphere in VPython. So if I start moving this around using the left and the right and the up and the down and diagonally, you can see I can kind of move the ball anywhere I want to in two-dimensional space. I keep saying three-dimensional space, but this is two-dimensional. X and Y, 2 dimensions. Silly Brian. All right. And when I press the button, that centers it back to 0 to reset it. And once again, we're going to use the cat talk button, and we're going to exit the program. Now we're also going to move this screen so I can find the little X button on my browser, or else we will have trouble. All right, so that was kind of fun. We used the joystick and the X and Y axis to move around in two-dimensional space. But what if we wanted to do in 3 dimensions? Could we do that? Well, as it turns out, we can. What I've done is I've added a potentiometer to my breadboard, and this is plugged into pin number 2 on the ADC0834 chip, and we can actually manipulate in 3-dimensional space using the joystick and the Z-axis potentiometer. So let's take a look and see what that's like. So here again, we've got our VPython screen, and we expect to see a sphere in the center. And I can move left and right and diagonally. But wait a second. That's not a sphere. There's something else going on. Maybe if I zoom in on the z-axis, I'll be able to see. Oh my goodness! Oh my goodness! It's aliens! It's aliens! It's an alien spacecraft! Oh no, it's coming for us! Oh good, it's flying away. It's flying away, and if I press the button, it centers it again. Charlotte, that was just for you. I got aliens into my program. And once again, we hit the cat talk button to cleanly exit the program. And now we will go and take a look at the code. All right. So like a lot of programs, I kind of use the same header here. I'm bringing in VPython and bringing in GPIO as Pi pins, setting my mode to BCM, and defining I have my joystick button as BCM13 and the cat talk pin, which is perpetually connected to 26. And then I've got my inputs set on my ADC. Like I said, X is pin 0, Y is pin 1, Z is pin 2. Run the setup, basically just bring this in. Now you'll notice that I'm doing a pull up here because I want to bring the GPIO pin BCM13 to pull up. That way when I press the button, it will bring it to ground and I can measure it that way. And in case you forgot, the cat talk pin is also wired pull up, except I'm using an actual, I don't know if you can see it here, I'm using an actual physical resistor as opposed to using the internal pull up mechanism in the Raspberry Pi. So I'm setting up, here's my XY coordinates, setting up my VPython environment. I'm drawing a boring gray box and then building the sphere and then giving the sphere a left wing and a right wing and coming down here. And now we get into the actual program. This is the while loop that runs constantly until we hit the cat talk button. So every time through the loop, I'm reading the input from the X pot, the Y pot, and the Z pot. You'll notice that I'm doing a translation here. This is just for VPython. Instead of reading in as 256, I wanted it to have a smaller value because if I read a full 256, what'll happen is that the object in VPython will come forward and it will actually scale the background smaller. So I don't get a nice back and forth motion. So I've divided by 6 just to keep that from happening. I'm really not an expert in VPython. I kind of have to fudge my way through it. I'm sure there's a much more elegant way to handle it, but in this case, that's what I did. I just took that 255 value and divided by 6 to make it a little more palatable to VPython. Then I'm reading in the inputs from the actual pins each time through the loop. So if the button is, or if the joystick is centered, we're getting about 128 on the x-axis and the y-axis. So if the x value is reading lower than 100, that means we're pushing to the left. If it's reading higher than 200, that means we're pushing to the right. Likewise, on the y-axis, if it's less than 100, we know we're pushing up. And if it's more than 200, we're pushing down. And you can see I'm incrementing my value. So every time I go left, I'm decrementing the value by 1. Every time I go right, I'm incrementing the value by 1. Every time I go up, I'm incrementing by 1. Every time I go down, I'm decrementing by 1. That way I can use a true XY coordinate in my VPython, and that way I don't have to do any translation. It's just true XY values. And then if the button is pushed, because normally this is going to be 1, if I press the button, bring it to ground, it's going to read 0. Then I'm going to zero out X and Y, which brings it to the center. So that just sets the values. Then I actually come down here and I print the output. You saw the output on, there it is, the left side of the screen as my program was running. There's my coordinate output. And then I position my sphere based on the X, Y, and Z values. And then the left wing of the alien spacecraft has an offset of X minus 1. and the right wing has an offset of x plus 1. And then this is kind of an important thing right here. There's a 200 millisecond delay that I've put in here. And the reason for that is because if I don't delay it when I push to the right, this number will increment basically as fast as the code can run, and it will run my VPython spaceship right off the edge of the screen and cause all kinds of problems in VPython because it'll force the background to rescale and I'll basically screw up the whole image. Um, by delaying it, this can only move so much every time I hit the button. So that's how I can hold this down and it moves to the right, it moves to the left, it moves up, it moves down. And what I found is kind of the sweet spot of smoothness of motion is about 200 milliseconds. And then of course we get down to the cat talk. This is kind of standard code here. I just do a quick cat talk. This is normally pull up. So I push the button, push it 3 times. We increment the cat talk, we exit the loop, and we clean up our Pi pins. So I hope you enjoyed this kind of tour and deep dive into how this stuff works. But now you're probably wondering, well, we covered pretty much everything, didn't we? We x-axis, y-axis. Why is this part 1? What else can we possibly talk about? And I'm going to tell you right now, this code has a fatal design flaw. Maybe you already saw it as I was walking through the code, but there is a major, major, major problem with this code. Um, I'm going to take some time to dig a little bit of a rat hole and go down into a topic I've been wanting to make a video on, but haven't really had the opportunity. The way this is set up using multiple inputs, I have now got the opportunity that I can talk about some of my really bad design that I've been carrying forward and then made more bad design decisions in this code. We're going to talk about what I did, why it's wrong, and then go back and actually rewrite the code in a much better way. So I look forward to seeing you on the next video. Look for a homework solution to lesson 18, part number 2 in an upcoming video. If you like this video, be sure to go below, hit like and subscribe, leave a comment. I am Brian from Simply Brian Enterprises. Thank you for watching.